This video covers the idea of instantaneous velocity. Instantaneous velocity is the velocity at a very specific moment in time. Previously, we have only discussed average velocity, which is the velocity over a large period of time. A good way to think about the difference between average velocity and instantaneous velocity is when you're driving down the street to go to the store, let's say in your car. So over the period of time that it takes for you to do this trip, we would say that your average velocity may be around 20 miles per hour. But your instantaneous velocity would be whatever the velocity or the speed that your speedometer reads at a given moment when you're in the car. Instantaneous velocity is really just like average velocity, but over a very, very, very small time interval. It can be written in equation form like this. Whenever we calculate instantaneous velocity in this class, we will do so by analyzing position versus time graphs. So let's say that our position versus time graph looks something like this, a series of straight lines. And we want to find the instantaneous velocity at this point on the graph. We learned from the previous video that the velocity is always equal to the slope of a position versus time graph. And whenever there is a straight line on a position versus time graph, we know that the average velocity is going to equal the instantaneous velocity, because no matter where you are on that line, the slope is always going to be the same. Therefore, the average velocity and then instantaneous velocity will also always be the same. So along this line, from 0 to 2 seconds, the average and instantaneous velocity are always going to be the same. And the same goes for this line. From time equals 4 seconds to 6 seconds. The instantaneous velocity will also be the same as the average velocity. So, unfortunately though, position versus time graphs are rarely composed of nice straight lines like this. Instead, they typically look like this, a series of curved lines. For nonlinear graphs, in order to find the instantaneous velocity, you must look at a very, very, very small portion of the graph. So if we want to find the instantaneous velocity at 4 seconds, you would want to zoom in and look at a very, very small portion of the graph. And if we zoom in, we see that the very small portion of the graph kind of looks like a straight line. When we want to find the instantaneous velocity at a particular point, we extend this small straight line to become a larger, more visible line. The line that we would draw is called a tangent line, which is a line drawn against a curve so it just barely touches the curve at whatever point you want to analyze. The tangent line should never cross the curve at the point you are analyzing. So the tangent line at this point would look something like this. So to find the instantaneous velocity at time equals 4 seconds, we need to find the slope of this tangent line. To do this, we first then pick any 2 points on the line. I decided that we are going to pick the points 2.5, 4, and 4.5, 5.5. So once we pick these points, we then use these values to fill in our velocity equation. So in order to make sure you fill in the equation correctly, you must make sure that the change in time is always a positive value. You don't want to go back in time. You don't want a negative time. So we want to make sure that we put the final time as 4.5 seconds and the initial time as 2.5 seconds. So our equation begins to look like this. You then plug in the positions that correspond to that particular time. So we find these position values from the points that we picked out on the tangent line. So at the time 4.5, we're at a position of 5.5, and at the time of 2.5, we're at the position of 4. So then we can simplify our equation, and we find that the instantaneous velocity at the time equals 4 seconds is 0.75 meters per second.